In example 4, we want to integrate cosine over 1 minus cosine with respect to x. So, my first thought is, okay, this is going to be a trig integral, and you would use a u substitution, but I don't see a function as derivative. They're both cosines here. So that makes me think we might have to use some trig identities here. And I see that 1 minus cosine in the denominator. If that was 1 minus cosine squared, we could trade it out for a sine squared. Well, we can get a 1 minus cosine squared there. So start with our cosine x over 1 minus cosine x. And then multiply top and bottom here by 1 plus cosine x. Because that's the conjugate of the denominator. All we did was change the sign. And in the numerator here, we get cosine plus cosine squared. And in the denominator, first terms, 1. Outer terms, negative cosine. So get that 1. Outer terms, positive cosine. Inner terms, negative cosine. Those cancel. And then last terms, negative cosine squared. So minus cosine squared. X dx. So now we can trade that out for a sine squared. So this will be integral cosine x plus cosine squared x over sine squared x dx. And then I'm going to split these apart over the LCD. So I'm going to write this as integral of cosine x over sine squared x, and then plus cosine squared x over sine squared x dx. So and let's do the integral of each piece. So this will be integral cosine x over sine squared x dx. And then cosine squared over sine squared is cotangent squared. So plus integral cotan squared x dx. So this one, I see a function sine x and its derivative cosine. So I'm thinking u substitution on that one. So for this one, I'm thinking u equals sine x, and du is cosine x dx. And then on this one, I'm thinking that, because we don't know antiderivative of cotangent squared directly, but we could use an identity and trade that out. So just like we have the identity 1 plus tangent squared equals secant squared, we have an identity involving cotangent and cosecant. 1 plus cotan squared is cosecant squared. So that's not used as much. So our cotangent squared, bring the 1 over as a negative, and we get cosecant squared minus 1. So here, let's go ahead and do our u, and then here's our du. So this will be du over u squared, and then plus integral. For our cotan squared, we're trading that out for cosecant squared minus 1. Integrate that with respect to x. So now du over u squared, that's just going to be integral of u to the negative 2 du. And then integral of cosecant squared. Well, remember, derivative of tangent is secant squared, while derivative of cotangent is negative cosecant squared. So we don't use that one as much. Cotan x is negative cosecant squared x. So that means if we do antiderivative of negative cosecant squared, we'll get back to cotangent. Well, we've got positive cosecant squared, so we'll get a negative cotangent. So instead of a plus here, this will be minus cotangent x. And then antiderivative 1, x. And then we'll add our plus c after we've done all the integrating. So then here, add 1 to the exponent, divide by the new exponent. So u to the negative 1, divide by negative 1, minus cotan x, minus x. So this will be negative 1 over u. If we bring that u down as a positive exponent, and our u here is sine x. So this will be negative 1 over sine x minus cotan x minus x, and now we'll add our constant of integration. All our integrating's done. And then our negative sine x, or 1 over sine x, we could write that as cosecant x. So negative cosecant x minus cotan x minus x and plus a constant. And we got it.